Today we will discuss about image enhancement in digital image processing. Last class we have discussed about the introduction to the digital image processing. So here we see that over the next few lectures we will look at the image enhancement techniques, especially in the spatial domain. And what is this image enhancement? The different kinds of image enhancement like histogram processing, point processing and neighborhood operations. To have a note on the gray levels, which we have discussed already. The gray level for an 8-bit image is going to be between 0 and 255, where 0 is black and 255 is white. So how do we get this number 255? It is 2 to the power of 8. So 2 to the power of 8 is 256. So when we start from 0 till it can be graded to 255. So in total we have 256 gray levels. There is no reason why we have to use this range. As I have told you, if you choose an 8-bit image, it is 2 to the power of 8. And if you choose a 2-bit image, it is 2 to the power of 2. For many of the image processing operations, we have the gray levels assumed to be in the range 0.0 to 1.0. That is, in the sense, the values are normalized. So the maximum value we will have is 0 to 1. Now, what is image enhancement? Image enhancement is the process of making images more useful. The reasons are: we have to highlight the interesting detail in images, remove the noise from the images, and making images visually more appealing. So this is the reason we have operations in image enhancement. Now let us see a set of images where image enhancement has improved the quality of the images. The spinal cord of the person is shown on the left in an X-ray image, where we can see the features are not very clear and they are on a black background. Whereas on the right hand side, the enhanced image shows the details of the spinal cord very clearly with all the vertebrae clearly seen. The next image shows the human skeleton. Once again, we see that the X-ray image is not very clear and the details of the image is missing. And on the right hand side, we see the enhanced image where the details are very clearly seen compared to the input image. When we take this PCB board, which is actually corrupted with salt and pepper noise on this side, and this noise removal gives a very clear image of the PCB board, and this shows clearly that noise is removed. So in general, image enhancement is useful for improving the quality of the images, which has the details in a clear way, and also for removing the noise. Whatever be the form of the noise can be removed by using various filters. And as told, this is a salt and pepper noise which is removed by the particular filter. Let us see later what are the filters which are used for removing various noises. Now, this image enhancement, it very clearly shows the details of the images in the image are clear when compared to the first image. Now, there are two broad categories of image enhancement techniques. As discussed earlier, in this lecture, we are going to discuss only the spatial domain techniques. But what is the other method apart from spatial domain technique? The frequency domain techniques or the other set of techniques for enhancing the image. So what is the difference between these two? The spatial domain technique is direct manipulation of image pixels. That is, we take the value, gray value of the pixel in the xy coordinate and start working out with that, and then we call it as a spatial domain technique. On the other hand, if we take a transform of the image, whatever be the transform, it may be a Fourier transform, a wavelet transform, a direct cosine transform, any transform for that case may be, and then work on the image, then we call it as a frequency domain technique. We all know that taking Fourier transform will convert the signal from the time domain to the frequency domain. Any transform for that matter in signal processing converts the time domain signal into the frequency domain signal. And as we have discussed already, we know an image is nothing but a two-dimensional signal. So when Fourier transform is applied on an image, it is converted into the transform domain, where that is the frequency domain. And when we work on the transformed image, we call it as a frequency domain technique. And now, for the moment, we will concentrate on techniques that operate in the spatial domain. Now, we will see about image histograms. So, what is a histogram? The histogram of an image shows us the distribution of gray levels in the image. We have seen the gray level of an 8-bit image varies from 0 to 255. Now, when we take an image, what are all the various gray levels which are available in an image, and what is the frequency in which these gray levels appear in the image? So, when a graph is plotted with the gray levels on the x-axis and the frequency of appearance on the y-axis, then we get an image which we call it as the histogram of the image. This is massively useful in image processing, especially in segmentation. So this tells at this particular gray level, we have so many pixels which are in this particular gray level, and this particular gray level has the highest number of pixels in the image. So the histogram gives us an idea of the various gray levels and the various frequencies of occurrence of these gray levels in a particular image. So we'll see here histogram, the example. So this is the Lena image, a very famous image, especially for image processing because of the various gray levels in this particular image. Now when we plot the histogram of the image, we could see the variety of gray values which are available and the distribution of the gray levels. As we have seen, the graph shows the values from 0 to 1 because they are normalized. So we don't have it as 0 to 255, rather it is 0 to 1. So 0 is 0, whereas 255 is 1, and all the gray levels between 0 and 255 lie between 0 and 1. And this is the frequency of occurrence of the gray levels. The Lena image is always useful for image processing because of the abundance of the gray levels available in the image and the distribution of the gray levels, say from the 0 value to the maximum value. Almost in all the gray values we have pixels occurring in the image. So this is an important image for any image processing application. So now look at this particular image, which looks very dull and it doesn't have any good clarity of the image. The histogram of this image, when taken, will clearly show that the gray levels are on one side of the graph. That is, they are not distributed. Let us see the histogram. Look at the histogram. The histogram very clearly shows that all the gray levels are on the darker side of the image, and that is why the image has got a very dull and black appearance. Now when we do a histogram equalization, these gray levels will be distributed to this entire values, and then you will have a better look of this image. The image becomes usually visually appealing. Now let us see another example. Now just look at this image, and here you can see the image is very bright, in the sense that all the gray levels are crowded on the right hand side of the histogram, that is all on the brighter side. Let us see the histogram. Now just look at this histogram. So all the gray levels are towards the brighter side of the histogram. That is why the image looks very bright and the look is not visually appealing. Now here we do see that this is neither blackish nor very bright, but it still looks dull, which means the distribution is not okay, and all the gray levels are centered towards the histogram. Let us look at this image. You see here, though the values are centered, they are not distributed. An image will usually look appealing only if the gray levels are distributed throughout the image. That is, we have values from 0 to 1. The image will not be appealing if the gray levels are crowded on in any one area, maybe either to the left where it looks very black, or to the right where it looks very white, or to the center where it looks dull. The contrast of the image is going to be very less in all the three cases, because the contrast is the difference between the lowest and the highest gray values. So when it is distributed, the difference is high and the contrast is also good. Now just look at this image. Now this is an image which is having a good appearance. Let us look at the histogram of the image. The histogram shows very clearly that the gray levels are distributed throughout the entire image to consolidate what we have seen now. So these are the four various images we have seen now, and they are histograms. As told, one of them, the histogram is crowded to the left side, and in one, the histogram, the values are crowded to the right side, and the other one, the values are crowded in the middle. So the distribution of the histogram is from left to right, and if all the gray levels are distributed throughout the entire histogram, then the image really looks good and the contrast of the image is also good.